Hello, everyone. I hope you are doing well. I hope you are safe and entertaining yourselves just fine. We are now in Chapter 7. We are so close to the end of the semester. What we're going to do, we're going to study something called paired data. Paired data is going to give us one quantitative response variable. I'll explain that later, but that's a good introduction for you to know. Chapter 7 will have 3 sections. So there'll be 3 videos you need to look out for. We'll cover 7.1 in this first video. Okay, so we have one quantitative response variable in paired designs. In paired data. Before, though, in chapters 5 and 6, we had 2 response variables that we were comparing. Why are we going back to 1? Well, let's answer that question by first looking at chapters 5 and 6. Chapters 5 and 6 had 2 long-run proportions, right? We were working with 2 groups. And chapter 6 had 2 long-run averages. There were 2 categorical variables in chapter 5, and then 2 quantitative variables in chapter 6. These chapters studied independent groups. When I say independent groups, I mean that the observational units in group 1 will not be related to the observational units in group 2. They are independent of each other. They don't affect each other in ways that we cannot observe or record. Here are a few of my favorite examples. If you're Walmart, you're looking at their customers, you could assume that customer 1 would not communicate or influence how customer 2 would buy products at the grocery store. And customer 2 would not affect how customer 3 interacts with your grocery products. If you assume that they are unrelated and they won't affect each other, and then they are independent of each other. Here's one more example. You're looking at sparrows, which are birds, all across the US. Therefore, you can look at sparrows that are in Nebraska versus sparrows that are in Massachusetts versus sparrows that are in Tennessee. These sparrows are so far apart from each other and they won't interact with each other that much that you can assume that they are unrelated to each other. Chapter 7 is interesting because we are working with paired data. Therefore, we make a paired design. These designs are realistic because it's saying a subject or an observational unit in group 1 is related to its partner in group 2. Observational units in group 1 are related to the observational units in group 2. To control this relation, we're going to put observational units into pairs. Therefore, we can say a pair is a observational unit. So please remember in chapter 7, each observational unit in the study will be a pair of subjects. You can see the prime example of this are identical twins. The girl on the left is very related to the girl on the right. I'll give you a few other examples later on. Okay, 2 features in paired designs you need to remember. Like I said, 1 pair of responses is an observational unit. And then we can frame or format the data to compare the 2 groups for every pair. So for each observational unit, there's going to be a comparison. For observational unit 1, we're going to have comparison 1. For observational unit 2, we're going to have comparison 2. And so on until we have a bunch of different comparisons. Here's an example from the book I like. 27 students will listen to music with lyrics or listen to music without lyrics. While students are listening to the music, they will play a memorization game. How do you play the game, Kevin? You will study a list of 25 five-letter words, study that for 90 seconds, and then the students will write down as many of the words as they can remember. Instead of randomly assigning students to one of the two groups, what we're going to do, we're going to have each student play the memorization game twice. Once listening to the song with lyrics, and then once listening to the song without lyrics. So the pairs in this study will be a student's attempt playing the game with lyrics, and then the second group will be the student playing the game without lyrics. So each student is going to play the game twice, and that one student's two attempts will make up a pair, or an observational unit. I told you about that we're going to measure comparisons for each observational unit pair. So you'll have comparison 1, comparison 2, comparison 3, comparison 4, and so on. This comparison is a quantitative variable. It's going to be a new response variable that you haven't been introduced to yet. That's because this comparison is going to simply be a difference between the two groups. Therefore, each observational unit pair will have a difference. That difference is the response variable. That's the data we are measuring. Since we're working with differences or subtractions, we can have positive differences or negative differences. So you shouldn't be afraid if you see observational unit pair 1 has a difference of -7. What do we do? You should say, nope, this difference can be negative, can also be positive, so this will be fine. I would read the book a tiny bit. Why differences are the new response variable. The best reason I can give you is that differences are expected to have less variability than if we would do an independent groups design. You'll have differences of 0, 2, 4, 5, -3. They'll be less spread out. But if you compared just two independent groups, you'll have a lot more of a difference that may be hard to understand or study. So I would read the book's example if I were you to understand this reason. If you don't want to read the book, I would just memorize that differences are expected to have less variability than if we worked with comparisons between two independent groups. Paired designs have two main types. The first main type is called the repeated measures design, where you measure each subject twice, once under explanatory group 1, and then once under explanatory group 2. Here's a real life example. I'm a horse breeder, making lots of money, and I have the temptation to buy a new horseshoe. Well, how do I know this new horseshoe will be better than my old one? What I could do, I could have each of my horses run a 100-yard dash, once with the shoes I'm used to, and then a second time with the new shoes that I may buy. I could compare how fast my horses are by comparing the difference in the 100 yards dash between the old horseshoe and the new horseshoe. So let's say this horse right here, his name is Secretariat. Secretariat would do the test twice. Once with the new horseshoe, once with the old horseshoe. And then this horse in the back is named Champion. Champion would also do the 100-yard dash with the old shoe, and then he would do it with the new shoe. Here's another real-life example. A person gets a medicine, and then they do this test again a few days later. That second time, they get a placebo. A different person could get the placebo first, and then a few days later, get a medicine. That's a repeated measures design. Second type is called matching pairs. An observational unit, which is a pair, are subjects that are very related to each other. So, two examples here. We could pair up two pigs that came from the same litter. We know that they're family, so they must be very related to each other. So we're just going to make them a pair. And we can see which feed will add more fat to the meat. So we would put one of the paired pigs to have feed 1, and then its closely related partner to have feed 2. Second, this one's fun. You could pair people based on their BMI, body mass index, to see the difference in the amount of push-ups they can do in regular clothes versus workout clothes. So we have this poor fella here. We would make him into a pair with a person that has a similar BMI to him. That can be a man or woman. They just need to be a similar BMI. And then the skinnier kid off to the right, we would have someone paired with him who has a similar BMI. So remember that the main two types are repeated measures and matching pairs. Paired designs have a few benefits that make them better than independent groups. They are that they can exclude almost all confounding variables just by themselves. You can say, oof, I have a lot of confounding variables I'm worried about. Let's see if this study is a paired design. If it is a good paired design, then we don't have to worry about the confounding variables that we were pondering about. That's a huge benefit. There are still two confounding variables that we will have to worry about and eliminate by following the following strategies. The first confounding variable is called order of tasks. And you would eliminate the task order, or the order of task, by randomizing which task is first, if you did a repeated measures design. So for Secretariat, I would randomize whether he would use the new shoe or the old shoe first. Then the second time Secretariat does a study, I'll just give him the other shoe that he didn't use. If we did a match pairs design, you would just simply randomly assign the group to each subject in a pair. So for example, this guy right here, I would randomly assign whether he got workout clothes or if he got regular clothes. Then whichever type of clothes he didn't get, I'll just give that to his partner. Okay, the second confounding variable we need to worry about is called carryover effects. Carryover effects means that there is going to be some effect that carries over to the second measurement that you get in a pair. That effect that carries over to the second part of the study can be fatigue. It can be some medicine that is stuck in the blood. It can be practice, right? Practice makes perfect. If you do a task multiple times, you'll get better at completing the task. Carryover effects would not be conducive or helpful for our experiment. So what we would do, we would use a rest period or a washout period to eliminate the fatigue, the practice, the familiarity, or you'll eliminate the drug from the body. So if you use a washout or rest period, then if you eliminate task order, you therefore have gotten rid of all the confounding variables that could make cause and effect conclusions impossible. Okay, you shouldn't use paired designs all the time. I did say that they have benefits over independent groups, but it's not like you can just turn any design into a paired design. I suggest using paired designs if you expect a strong relationship between observations within a pair. So if you're working with twins, definitely use a paired design. If you're working with people that will be related to each other, use a paired design. Or animals that are in the same family, use a paired design. There may be some other situations. You just need to be careful to say, are my observational units in one group going to be related to the units in the other? Then second, you can consider, are comparisons going to be more helpful? And are they going to give me better answers? If that's the case, then you should take advantage of those comparisons and use a paired design. Before and after situations are great for paired designs. Okay, last little bit. In paired designs, since we're working with one quantitative variable, here's what our parameter will be. It'll be the long run mean difference of whatever you're studying between the first group and the second group. So you can notice here there'll be some blanks, such as the long run mean difference of blank, and then you'll have to tell us what group 1 is and what group 2 is in context of the study. Be aware, long run mean difference is very important, and it is different than chapter 5 and 6. So I would just memorize this. Long run mean is first, difference is second. Long run mean difference. That's because we're going to have a bunch of differences in our data, and we're going to average them up, making the mean of the differences. since we're going to work over the long run, this is going to be the long run mean of the differences of blank, blank, blank. We're going to assume that the long run mean of the differences between two groups is 0. Then for our alternative hypothesis, we're going to say that the long run mean difference is going to be different than 0 in some way. It's going to be either greater than 0, it's going to be less than 0, or not equals to 0. You pick the sign, greater than, less than, or not equal to by reading the question carefully. We don't know this long run mean difference most of the time. So what we're going to do, we're going to gather a sample of observational units, and we're going to get sample statistics there and hope that our sample statistics will help us make conclusions about the parameter. Sample statistics here is first a sample mean difference. That symbol is just going to be X bar with a little d underneath it. Then the differences will have a sample standard deviation. That symbol is S with a d under it. You see little d's popping up for all these symbols. You need these d's that stand for difference in Chapter 7. Here's an important note. Observational studies can have paired designs as well. So if you see a question on a test or exam that says, is this an observational unit? Is this an observational study or is it an experiment? Once you answer that question, please remember that either of those studies can be paired designs. So you just need to read the question carefully to decide, am I working with the independent groups or a paired design study? Okay, let's do an example to see what questions would be like. Okay, so let's look at student researchers. They were big fans of Jeopardy, and they wanted to see whether an adult's reaction time would be different if they hit a button once they see a light flashing, or if they hear a noise. So we're going to compare flashing lights to a loud noise. They randomly sampled 55 adults. To start, the adult subjects would have both hands behind their back, just like they would in Jeopardy. Then the researchers would have a computer program display a red circle. When it flashed, when the red circle flashed, or when the computer made a loud noise, subjects were to hit the red circle or the buzzer as fast as they could. The computer would calculate the reaction time in milliseconds. Researchers recorded the reaction time. Each subject did the test twice. And then the researchers randomly determined which test, flashing button versus a noise, was completed first. Since each subject did both tests, I'll write a few notes right here. Since each subject did both tests, and we randomly determined which test was first, there's going to be pairs here. So these two phrases are clues that we're going to work with a pair design. If this is a paired design, what type is it? Justify your answer. So since each subject did both tests, that means that we're going to work with a repeated measures design. Each observational unit was in both explanatory groups. So you would say each subject did the test with a flashing button. And then they repeated their test. With a noise. Or vice versa. I could have done it the opposite way. Other keywords that could help you answer future questions. I noticed that I'm wanting to see whether an adult's reaction time is just different if they hit a button once they see a flashing light versus when they heard a noise. So difference is going to tell me I'm going to work with a not equals to sign when I make an alternative hypothesis. Randomly sampled 55 adults. So there'll be 55 pairs in the repeated measures design. The two groups were a flashing button and hearing a noise. And then we're going to record the reaction time in milliseconds. So each observational unit pair will have the difference in reaction time, and that difference will be computed using milliseconds. Reach out to me if you have any questions about this problem. Here's a second example. On March 19th, 2019, you may remember this, Lincoln residents and businesses were urged to continue to voluntarily reduce water consumption by 25%. This happened because of all the floods that Nebraska experienced last year. UNL's Institute of Agriculture and Natural Resources wanted to see if voluntary water restrictions reduced the amount of water that was consumed. They did a little experiment here. They delivered flyers to 200 apartments at Old Cheney Place. They randomly gave a flyer notifying residents of voluntary water restrictions. They gave those flyers to a treatment group, which was 100 bedroom apartments. For the control group, they gave a flyer to 100 other apartments. The flyers only advertised the Kasner Week food drive. So 100 apartments randomly knew about the water restrictions, and then the other apartments didn't know anything about these water restrictions. They only knew about the food drive. Do you think each apartment will be related to each other? Do you think each apartment will affect how the other uses water? I don't think so. I don't think my neighbor is going to change how I use water. Therefore, this design will be best if it was an independent groups experiment. If it is a paired design, what type is it? Well, it's not a paired design. one apartment won't affect how another will use water. Okay, if not, how could you make this a paired design? Interesting question. How can we make this independent groups design into a paired design where apartments will be related to another? Here's an idea. You could say on March 19th, you could give an apartment one type of flyer. That could be either the food drive or water restrictions. Then 1 week later, you would give them the flyer that's left over. And you could compare that apartment's water consumption the first week with the water consumption that was in the second week. See if the first week had a difference between the second week. So you can see right here, this will be a repeated measures design. Since an apartment will do both tests. Second, we're going to work with a washout period. That washout period is 1 week. Awesome, we are done with this problem. Let me know if you have further questions. But please remember, this study is best as an independent groups design, and therefore paired designs won't always be the best solution or the most appropriate solution. Please reach out to me if you have further questions, though. I'm happy to talk. What I want you to do to end 7.1, there's a 3-question assignment. I want you to come up with your own study. First, I want an example of an independent groups design. If you need to brainstorm about some ideas, look at Chapter 6 or Chapter 5. Second, I want you to come up with a repeated measures paired design. Then last, I want you to come up with a matching pairs design. How can we think of a way to make partners related to each other? So yeah, this will only be a small portion of grade. It's more of like a survey. I just want to see your ideas of how you can make an independent groups design a repeated measures paired design, or a matching pairs paired design. It'll be fun to read your ideas. It'll be awesome. Okay, we are done with chapter 7.1. But reach out to Dr. Vanderplas tonight if you have questions, and we'll have fun with this chapter. It'll be great. See ya.